Hi, welcome to Bear Witness. I'm Robert Bettis. The past couple videos we have been talking about dolphins. Well, it's supposed to be a month long of dolphins. We're not going to do that. After I did a lot of researching and after I've gone over notes of my own previous studies, I have noticed that they all do the same thing, travel the same way, and almost eat the same things. Now, we're going to change it up today, and we're going to do something totally different, and that I think is very important for someone to know. So sit tight, hang on, and let's go. So today, we will be talking about the properties of water. The main constituent, which means part of a whole, is water. That means our world is mostly water. The presence of large amount of liquid water on Earth resulted from a fortunate combination of factors. Among these factors are water's high freezing and boiling points for a molecule of its size and chemical stability. A molecule of water, which is H2O, consists of two hydrogen atom bonds to one atom oxygen. So four tiny negative charged particles called electrons are the bonds between the hydrogen and the oxygen. So let's talk about surface tension. Surface tension is the property of a surface of a liquid that allows it to resist an external force. Sea skaters and water spiders exploit surface tension to walk, feed, and breed on the surface of ponds, lakes, and the sea. So just imagine these little insects, and you've probably seen them push themselves on top, or they land and they glide over. Those are these sea skaters and the water spiders. And in any form of water, the fish love to eat them. They'll come up out of the water, bass especially. They'll come up, eat them. And bass, if you don't know, are in fresh water. They're not in salt water. But if you go to salt water, then perch love them. Even some smaller redfish love to come up and eat them off the surface. So next time you see them, just know that surface tension has a lot to play in their survival. Now let's talk about specific heat capacity, which is abbreviated as SHC. This is the energy in joules needed to raise the temperature of 1 gram of a substance of 1 degree Celsius. So think about this. You put water into a pot. You put the pot onto the stove. At this point, joules from that energy of heat helps that water temperature of 1 gram goes up 1 degree Celsius. So for every time it gets hotter and hotter and hotter and hotter to the point where you can only hold your hand above the pot, because remember, heat rises. So you can only hold your hand above the pot and feel the heat coming off. That means every degree of that Celsius is getting hotter and hotter and hotter by 1 degree Celsius of that 1 gram. So there are 3 states of water. The temperature at which water changes between its 3 states. Melting point, from ice to liquid water. And the reason being is because it gets so hot and it's melting the ice into liquid water. Which other people be like, well, water's liquid. Well, there's, again, 3 different states. Ice, the water's frozen. Liquid, which means it's just regular water. And then it's boiling point, which is liquid water to water vapor. So you're going to boil this water and you see smoke coming off, but it's not smoke. It's water vapor, which means it's going to get so hot from boiling, which it gets so hot, it's going to release into the air as smoke, but it's really water vapor. Another cool thing that I love about science is that everything has images, everything has a name, and everything has its purpose. The one thing that I want to talk about right now is the molecules of ice, liquid water, and water vapor. So the molecules of ice has a hexagonal liquid lattice, which means it looks like little bitty hexagons come together to make up the molecule of ice. And the reason why it is compact together is because nothing's moving, because it's frozen. It is so cold that these molecules cannot move back and forth to one another. It just has to stay in its place until it reaches its melting point. Then the molecules become loose and they move back and forth, bouncing on and off one another. Now this takes us to our molecules of liquid water. The molecules of liquid water are small clumps of bonded molecules, which means here is your hexagonal crystal lattice. Okay, it doesn't move, it's here. You're gonna melt it of 1 gram of a substance of 1 degree Celsius. So now it goes from ice to liquid water. So it's here and it goes here. Okay, now you have liquid water molecules, which they're gonna move more flowy, not as slow. They're gonna move together. Okay, at this point they're in little bitty groups. Okay, they're just in little bitty groups here. So they're going here, boom, 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 moving in a motion to stay in that liquid form. So now let's put this water into boiling form. Okay, we're gonna now get into the topic of water vapor and its molecules. So the molecules of water vapor is widely spaced, unbonded molecules, which means you went from here, okay, no moving, to here, a little movement, to here, which means it's just roaming around. And the reason for this is because there's no physical state. It's just vapor, like smoke. It moves freely. There is nothing holding it together. There's nothing keeping it bonded. There is no connection between the negative and the positive charges. Pretty much what is happening is the state of water vapor is that negatives are hitting each other and bouncing off, bouncing off, bouncing off. To have a connection, you need a negative and a positive coming together and they latch on together. In this sense is negative and negative hitting and positives hitting to where there's nothing to hold on to. Now this information isn't for everybody. For me, I'm a science person. That was my best subject. Well, and history and lunch, but you know, whatever. But the ones who do like this stuff will appreciate it. Even the ones who don't, they'll appreciate the information behind it. And the reason why I wanted to do a video about the properties of water is because I wanted everybody to understand what goes into a water droplet, what goes into a sea, a river, a lake, a handful of water that you put from your sink to wash your face. All of this has a state. When you put your ice in your cup to make it cold, that has a state. When you boil pasta to make spaghetti and you see the water vapor come off, that has a state. I think it's important for people to know everything around them is science. Everything they touch has an atom. Everything, even ourselves, we have atoms and we have states and we have a purpose just like everything else. So I want to thank you today. And I want to leave you with this information, and I want you to go when you take a drink of water, when you go swimming, when you go take a shower, when it's raining and you're driving. Think about these 3 states of water, and I want you to comment back to me and see if it changed your perspective on everything. This is Bear Witness, and I'm Robert Bettis. Have a great day. Thank you. Bye.